I'm Ryan Muir, and at the laboratory I do ultrafast diagnostics as well as information processing, signal processing. On the NIF, as well as on related projects of NIF, there's a general interest in being able to measure the laser beams going through the system with very high fidelity. There are some systems in place, but the resolution of the available systems in terms of temporal resolution is actually quite low compared to where we'd like to be able to measure. So the instrumentation that I've been developing really tackles the resolution problem. We're trying to look at finer and finer slices of time until we can really see exactly all the information that there is present to be able to be seen. The original idea for this was to do this in a waveguide, actually. In the waveguide approach, we would be able to access the information as it traveled through the waveguide. And we showed that it worked, but only if we have an ideal waveguide, which is actually, for a slab waveguide, can be difficult to manufacture. So we wanted to have a process that was more robust, and we ended up coming to a free space design, which is our current technique. Free space meaning that we're not traveling through a confined medium. We're literally shooting lasers around, just around free space. So this technique ended up getting us even more resolution than a waveguide approach would get us, and ends up simplifying the design even more, nicely enough. I've really seen this being impacting in several different areas. For example, in life sciences, being able to capture high-speed information can be really important. And sometimes you really only do get one look at it. In some cases, having a high-speed camera can really help with this. In other cases, for example, in major areas of laser research, there's many different institutions around the world that do very high-speed, high-power lasers. And this is going to be just as important for them as it is for us. In other areas, such as, for example, telecom, there's incredible amounts of speed happening in the world of telecom. And if you're looking at an information packet, you really do only get one chance to look at it in some cases. And so that would be another different application area. So we're continuing to make Slicer a more and more of a complete and finished product. We're right now working on improving the sensitivity and scalability of Slicer. We want to push out the record length to even further lengths. We want to push the resolution down to something even tighter to come up with the most impressive piece of hardware we can at the end.